Once used for anesthesia and as a narcotic, then replaced with diethyl ether because its high toxicity, often useful for some organic reactions, and very functional as an extraction solvent. Yes, I'm talking about chloroform or trichloromethane. Chloroform is a very famous central nervous system depressor, and because of that is often associated with kidnaps and things like that. The reality is that it is not that effective because you should expose the person for several minutes. Not an advice. As I said, chloroform could be used as a useful reagent in organic synthesis. It is employed on the synthesis of formic acid, isocyanides, very stinky stuff, salicylaldehyde used in the Raymer-Tiemann reaction, and in the dichlorocyclopropanation of alkenes. On the other hand, chloroform is produced by the direct chlorination of methane, producing also tetra, mono, and dichloromethane. Other very popular route is the haloform reaction of a methyl ketone. Using, for example, sodium hypochlorite, a methyl ketone will transform into a carboxylate and into chloroform. For the haloform reaction, sodium hypochlorite present in bleach solutions and acetone in nail polish removers could be used. So in this video I'm going to perform the haloform reaction of acetone using 13% sodium hypochlorite. For this experiment you will need 151 ml of acetone, 4 liters of sodium hypochlorite and 5 grams of calcium chloride for drying. First, we have to measure the concentration of the sodium hypochlorite solution, and it's necessary to set up a system like this. In the addition funnel we have 3% hydrogen peroxide, and in the round bottom flask, 1 milliliter of sodium hypochlorite. Slowly start dripping the hydrogen peroxide into the sodium hypochlorite, and oxygen gas will start generating. Based on the volume of air displaced, we can calculate the concentration of the sodium hypochlorite solution. The reaction goes like this. Hydrogen peroxide and sodium hypochlorite react to form water, sodium chloride, and oxygen gas. Using the ideal gas law, I can estimate how much oxygen I got. The final volume of the gas was 48 mL. The ideal constant is known. The approximate pressure of my city is 84 kilopascals, and the temperature was 300 Kelvin. The only thing we don't know is the number of moles, so we have to clear this value from the equation. After replacing everything, we got the number of 0.0016 moles of oxygen. This exact same quantity corresponds to sodium hypochlorite since the reaction is 1:1. Using the molar mass, this moles corresponds to 0.12 grams of sodium hypochlorite. Dividing this value between 1 milliliter and multiplying by 100, we get our final results of 12%, a little bit lower than the 13% they sold me. Here you can see the final volume of the gas. First, I let cool the 4 liters of sodium hypochlorite solution in a freezer for one night or till the temperature is below 0°C. It's very important to be below 0°C because the reaction we are going to perform is extremely exothermic and the product is very volatile. I poured approximately 500 ml of the solution in a beaker to have more comfortable mixing. On the beaker I added 19 ml of acetone very slowly, and on the bottle the rest of the acetone. I mixed well the both solutions using a glass stirring rod. Very soon, cloudiness appeared. While this is reacting, let's discuss what's happening here. 3 moles of sodium hypochlorite reacts with 1 mole of acetone. The first step is the deprotonation of an alpha hydrogen of the acetone by sodium hypochlorite, producing sodium hydroxide. The alpha protons of the product, chloroacetone, are even more acidic, so the process repeats 2 times. Then hydroxide attacks the carbonyl carbon of the trihalogenated product, kicking away trichloromethanide anion. A proton transfer occurs, and this way a carboxylate acetate in this case, and trichloromethane or chloroform is synthesized. After some minutes, the mixture got very hot. It went from -Celsius to approximately 50. I use an ice bath to prevent evaporation, but despite that, some chloroform boiled. After letting rest the solution for one night in the freezer, this chloroform layer separated. Then I decanted the upper organic layer. I mixed the both remnants. I put them in this bottle and added some scoops of table salt. I mixed the bottle well to separate as much chloroform as possible. I decanted most of the water layer and transferred everything into a separatory funnel. I separated the chloroform and in total made 2 washings with saturated sodium chloride solution and 1 with distilled water. 50 milliliters in each. I'm only showing you the last one. To the chloroform, I added approximately 5 grams of calcium chloride in order to remove any water left. I filtered the chloroform through some filter paper and set up a fractional distillation apparatus. I discarded the very first 5 ml of the distillation and the last 5. I weighted the chloroform distilled and in total I got 148 grams. I measured the volume and dividing the mass between the volume, I got an experimental density of 1.467. In the end I got a yield of 60.7%, which is not bad for me. So that's it for today. Thank you for watching and please subscribe. See you in the next video.